Hello friends, good evening. Today I am going to discuss about familial hypercholesterolemia. Okay, which is an autosomal dominant disorder. Let's go. So, what is familial hypercholesterolemia? Why it is occurring? It may be occurring due to the LDL receptor defects. In 90% cases, it is LDL receptor defects. Another PCSK9 gene mutations. Because if these two reasons majorly, that familial hypercholesterolemia is occurring. So normally what will happen, we'll take food in that there is cholesterol present. This cholesterol in the villi of the lacteals is getting converted into chylomicrons. What are chylomicrons? Protein coated fat molecules. These chylomicrons enter into the liver after getting disintegrated into triacylglycerol and apolipoproteins. And in the liver, from this chylomicrons, there is an endogenous synthesis of VLDL. VLDL consists of B100 as major apolipoprotein and ApoE. So this is VLDL. After that, this VLDL it is entering into the bloodstream. In this, one enzyme will be apoprotein lipase. Means lipoprotein lipase. So there is a breakdown of VLDL occurring into and this triacylglycerol and cholesterol will provide energy to the skeletal muscles and that it will loses apolipoprotein E, and it is becoming IDL. It loses another apolipoprotein C and it is becoming it is losing apolipoprotein C and is becoming IDL, and it is losing apolipoprotein E and is it is becoming LDL. This IDL can directly go on bind to the LDL receptor and enter into the liver. Otherwise this IDL will be converted into LDL and is going into the liver with the help of LDL receptor. LDL receptor has both the ApoB or ApoE recognition centers. Okay, this is what all happening. After that, what will happen now? How will LDL get endocytosed? We will discuss receptor mediated endocytosis of LDL. This is cell membrane if we assume it, and these are clathrin coated pits. Now what will happen? Now this is our rough endoplasmic reticulum. Here these are ribosomes. From this ribosomes there is a protein synthesis, like apolipoproteins. Every protein synthesis begins in ARIA. So it is getting transported into Golgi apparatus, where the protein gets packed. Okay, these are receptors, LDL receptors. Now receptors production which is happening in the RER, rough endoplasmic reticulum. Otherwise, the apolipoproteins is also happening in the endoplasmic reticulum. So, then what will happen? Our LDL will get entered here. So, LDL receptors will recognize it. After this, cell membrane along with the LDL gets pinched off and form coated pits. After that, this will bind to the means lysosome, and hydrolysis occur using cholesterol esters. This is controlled by NPC1, NPC2 genes, and triacylglycerol. This cholesterol esters get stored, and this is free cholesterol, which is free cholesterol, which is helpful in the steroid synthesis. Steroids means steroid hormones. Steroid hormone synthesis, myelin sheath, and bile salts, bile pigment synthesis. And these cholesterol esters means they will get disintegrated into cholesterol. HMG CoA reductase. Negative feedback, this HMG CoA reductase will be inhibited, and okay, this is like some just, and after that what will do? Normally for chylomicron says V48 apolipoprotein. For LDL, there LDL, VLDL, IDL. This is B100, B100, B100. Why only B48 means RNA editing. At 48th amino acid, there will be stop codon coming. Stop codons means UAA, UAG, and UGA. So then the translation gets stopped there, and we will get B48 means 48 amino acids. One. Here complete after 100 amino acids, the translation will be stopped by the stop codons. After that, what will happen? Okay. Now we have transporter defects. Yes. Last last one is synthesis defect. Synthesis of protein is defect. Next, transport defect. LDL transporter is mutated like that. And class 3 there is a binding defect. In class 4 there is binding and cluster formation defect. Some receptor formation defect. Is on the classes in which we are seeing major defects in the metabolism, and we'll discuss in case of familial hypercholesterolemia what is the treatment. Treatments are the statins, which are competitive inhibitors of HMG-CoA reductase. So when you use statins, majorly neostatins. This will inhibit HMG-CoA reductase, so there will be no cholesterol synthesis occurs. If there is a defect in PSK9 gene, it will be inhibiting receptors, no production of receptor. So it will inhibit so much, there will be no receptor production. Then free LDL will be circulating in the bloodstream. Then it will be very dangerous. It will enter into the scavenger mediated mechanism, and there will be formation of cholesterol streaks and foam cells, which will get into the blood vessels, tunica intima of the blood vessels, all we know, and blood supply to the heart will be decreased, then MI may be occurring. So this is very dangerous. LDL receptor should be sufficient for receptor mediated endocytosis. If there is a defect in LDL receptors, scavenger mediating this mechanism which is occurring, so it is becoming somewhat risky. Okay, that's for today. Thank you.